You should just have made an accurate drawing of the graph of y equals x squared, according to scale here. If I look at a slightly better sketch, and I deliberately haven't done mine to scale, because I want you to work this out for yourself in a minute, got a slightly better one here, just some of the points highlighted. What we're trying to do today is to find the gradient of the curve at this point down here, at the point 39, that point on the curve. And what we're going to do to start with is try and find the gradient of this line. Now, on your accurate drawing, I just want you to draw this straight line joining the point 39 to the point 416. And I want you to make a right-angled triangle with that as the hypotenuse. So I want to come along the horizontal distance and down in the vertical distance to make that right-angled triangle. And then we're going to work out the gradient of the diagonal line, the sloping line, by working out the height and the width of this right-angled triangle. So the width, the distance along the bottom, well, along the x-axis, it went from 3 to 4. So that has got a width of 1. And if we look at the vertical distance, that was along the y-axis from a height of 9 up to a height of 16. So that's got a height of 7. So the gradient of that line will be the distance it's gone up divided by the distance it's gone across. What I want you to do somewhere on a bit of paper, maybe underneath, is just say, we've got a table, we're going to have the gradient here of the point joining, or the line joining 39 to 416. 39 to 416, we've got the gradient there is 7. So if we can get that done and just check you get the same result as me on that bit, please. To make a better estimate of the gradient of this curve, what we're actually going to do is drop this top point down the curve. So what I want you to do now is see if you can mark off this point here, which is a point at 3.5 along the x-axis. To find out what the y value will be, well, y equals x squared. And if you square 3.5, you should get 12.25. And what we're going to do next is to draw a straight line joining that point to the point 39. And then we're going to find the gradient of that line. And I'm hoping you can see that as these diagonal lines get shorter and shorter and shorter, what's happening is the first one had that gradient, the second one had that gradient, and as we bring it down and down and down, the gradient of that straight line becomes closer and closer to the gradient of the tangent to the curve at the point we're interested in. And the only way we can define a gradient of a curve is by looking at the gradient of the tangent to the curve at that point. So if I just make a sketch over here of a curve and I want to know the gradient of the curve at that point, what I really need to do is the gradient of the tangent to that curve. Tangent, remember, is where the straight line just touches the curve. And what we're doing over here, by bringing this top point closer and closer to the bottom one, these lines will have a gradient closer and closer to the gradient of the tangent to the curve at this point. But before I go any further, can we try and work out what the gradient of that line there is? If I just do a little sketch here, I've got one x coordinate now of 3, the next one of 3.5, the y coordinate 12.25, the y coordinate at the top 16. So what's the horizontal distance now in this smaller triangle we're putting in here? Yeah, half. And what's the y, the vertical distance between 16 and 12.25? 3 and 3/4. Okay. So to find the gradient now between 3.9 and the next point 3.5, 12.25, I need to do the 3.25 divided by a half. And if we get that answer, we'll get the gradient for that one. Okay. What is 3 3/4 divided by a half? Anybody? 6.5. It actually is, yes. So what we've got now is the gradient of this line is 6.5. The first one was 7. This one is 6.5. And I'm hoping you're seeing that the gradient of this line is closer to the gradient of the tangent down here than the gradient of our first line. It's just been pointed out that the triangle I sketched over here had the wrong y coordinates on it. The lower one should have been 9, the height here. Upper one should have had a height of 12.25. So I've just changed those there. That should have been 3.25. The gradient would still have worked out there to be 6.5. So that change should have been made. Thank you to James So for spotting that one. Next thing I want to do is actually move this top point down the curve again. It started off here. We've moved it down here. What I want to do next is put it here, halfway between the 3 and the 3.5. So that will be at 3.25. So the x value down here now, I'm looking at this time, is going to be 3.25. If I just do another sketch to make it a little bit clearer what's going on, we've got our curve, and I'm now looking at the point at the bottom will still be 3,9, and the point I'm looking at now has got an x value of 3.25, and the y value to go with that will be whatever 3.25 is squared. Can anybody tell me what 3.25 is squared? 10 and 9/16. Okay. So the gradient joining these two, if you want to draw the diagonal line in, if you want to do a little separate sketch to show you what's going on, you can do. Okay. Got my right angled triangle here. Along from 3 to 3.25 is 1/4. Up the side from 9 to 10 and 9/16 is 1 and 9/16. And the gradient of that line will be the going up the side one divided by what's on the bottom. And that gradient works out to be 6.25. Okay. So that's the calculation. So just going back to what we had earlier on, and that will appear back on the screen for those in my class in a minute. What we have now got, we've got that line had a gradient 7. That line had a gradient 6.5. We've now come down again. The next line has got a gradient of 6.25. And as this point is getting closer and closer to the point we're interested down here, the gradient was 7, 6.5, and it's now 6.25. And we can write that one down here in our table when the x value is 3.25 and the y value was 10 and 9/16. We're getting a gradient of 6.25. I'm hoping you can see that the gradient is becoming closer and closer to something. It seems as if it's narrowing in, homing in on something. And in a minute, we'll look at exactly what it's homing in on. Okay, the table we've been building up at the bottom is showing what the gradient of these lines are as they're getting closer and closer to being just a tangent to this point down here. I've got 7, I've had 6.5, we've got 6.25. Some of you might think those numbers are getting closer and closer to 6. Okay, what I want to do now is look at not just a number example, but a sort of an example, sort of general case. So can you just sketch this part of the curve? It's going through 3,9. It's a y equals x squared curve. And over here, this point is going to be 3 plus a very, very small amount. I'm just going to call that h. 3 plus h, where h is a very small amount. So, if h is a very small amount, I'm actually going to put my triangle in right now. That means h is this distance along the bottom. I've gone along the curve the very small distance h. So my x-coordinate on this curve will be 3 plus h. What will my y-coordinate be there? What will my y-coordinate be on the curve y equals x squared if x is 3 plus h? All you need to do is stick the x value up here. So what will you get? If the x is that, y is x squared, what will y be in terms of this thing here? Sorry? Not just h squared, because the x value isn't just h. The x value is all of this thing here. So it's x squared, x is the 3 plus h, the y coordinate will be 3 plus h, all squared. Okay? Just the same way that earlier when the x coordinate was 4, the y coordinate was 16, that was just that thing there, 4 squared. So here the x coordinate is 3 plus h, the y coordinate is just this thing here, squared. 3 plus h squared.